Hello and welcome. In this video, we are going to create a starter app based on Webpack for ReactJS with TypeScript. We're going to set up tools like Jest, Prettier, ESLint, Sass, amongst others. We're also going to configure hot module replacement for ReactJS with Webpack. And so what is Webpack? Webpack is a bundler for JavaScript. And as you may have noticed, in the recent years, bundlers have claimed the place of the so-called task runners like Grunt and Gulp. A bundler is a tool that helps developers to combine multiple JavaScript files and resources like style sheets, images, and others into a smaller number of files, which can be efficiently loaded by a web browser. And this process is known as bundling. We have various types of files, JavaScript, source maps. Let me expand so that we can see it. Source maps, we also have CSS, and also we have assets like SVGs. We can have also many other types of files. And you may ask the question, why Webpack? Well, there are various popular bundlers nowadays. We can actually see a comparison of those here in this website. We have Rollup, Parcel, and even Browserify. Here we can see a comparison of their weaknesses and strengths. But because more or less all of them address pretty much the same type of problems, even though you may end up using a different bundler other than Webpack, having robust knowledge in one of them will help you understand much quicker any of the rest. And because Webpack is highly modular and configurable, it has great documentation. You can see it here. That's why working with it will give you a very good overview of what is to configure a JS project from scratch. Especially for ReactJS projects, given that the most popular starting project, Great React App, is also using Webpack, I think that learning Webpack is the definite choice. I can show you a project that has been ejected with npm run eject, and we can see here how extensive is the Webpack configuration of that project. So obviously, if we have a good understanding, we can configure some aspects to it to better fit our use case. And how can you take the most out of this tutorial? Well, in this video, we're going to follow the detailed README I have created as part of this project. It's in the form of a notebook and explains most of the aspects that we are going to cover in this video. Also, this project is published in GitHub, and you can find a link to it in the description. And without any further delay, let's dive in. Okay, now we're here with an empty project. We only have the README file. So let's start installing the packages. First, we're going to initialize the Git repository along with the git ignore file. We're going to ignore the VS Code, the IDR, and of course node modules. We're going to start the npm project. The Y option is for accepting all the default answers of the questions, and here it is how it's going to look like. Just default structure, which is fine for starting. Okay, and next we're going to install React and React DOM. And React DOM is because we're going to have a web-based project. Next packages are related to TypeScript, the TypeScript itself, and the type definitions for React and React DOM. And those are, of course, development dependencies. Most of the dependencies that we are going to install are actually development dependencies. Now we're going to install Webpack and a few packages related to it. The Webpack CLI, the development server, and the HTML Webpack plugin. We're going to see these two packages in more detail later on. Okay, this lasted a little bit for the dependencies that last I fast forward, so it might look really quick here, but when you install it, you may notice that it takes time. This next module is about it's a loader, so-called loaders for Webpack, which is for Webpack to run the TypeScript compiler when we run Webpack. And now we are going to install packages related to the testing infrastructure. Okay, we're going to install Jest for test runner, and from the testing library, we're going to install 3 packages related to React and Jest. Right, the next module we're going to install is for Jest to run in a web-based environment. In the past, as I read, this has been part of the Jest core itself, but now they have decoupled it and it should be installed additionally. Right, the next one, identity object proxy. This one is a little bit difficult to understand, but in general, what it does is to mock some code for the Jest to be able to use it. And in this case, we're going to set up the so-called CSS module isolation, and we are going to import SCSS code directly in our TypeScript code. So this is necessary because of this reason. In a minute, we're going to see how we're going to set it up in the Jest configuration file. Okay, and the last 2 packages that we're going to install as part of this testing infrastructure are the tsgest. This is a code transformer for Jest that is transforming the code that Jest wouldn't understand. And those ones are the type definitions for Jest. Okay, and what is left here is to create a Jest configuration file. I'm going to take the content from here and I'm going to create a file called, it's a JavaScript file. Oops, I have a typo. It's Jest. Okay, so exploring these values here. This is the plugin that we just installed, the code transformer. This is the environment that is a web-based environment, and this is related to this package. So we are telling Jest to use this package for environment. Next, module mapper is for mapping one module to be one or set of modules to be executed by another module, and we are here mapping this plugin that we installed for transforming or mocking this CSS SCSS files when we use them in our TypeScript code. I have also included the documentation here. This configuration is for making some of the so-called matchers for the DOM environment available in all our test files. And if we let me show you here what those matchers. For instance, when you search for examples for testing React, and you see some of the examples are using some of those matchers, and then if you don't have this configuration and try to use them, you'll get an error in your test. This value here is instructing Jest to execute this code right before the execution of every file. That's why this becomes available. So here is the precise documentation for this, where you can read what it does actually. And so with this, we have concluded the configuration of the testing infrastructure for the application. And we're going to test this when we have some code later on in the video. Now we're going to create some files so that we have some project files to work with. Let's create index.html. It will contain this HTML. Okay, next, this is going to be a simple React component. And the next one is going to be the entry point, index tsx. And why is it necessary that it's tsx, that it has an extension called tsx? It's because it contains JSX, and as you can see, it is underlined as an error because it complains that it's missing import of React. And we're going to see how can we make sure that we don't need this line. And next, let's create a TypeScript configuration file. It's going to be called tscofig. It's a JSON format, and it's going to have this content. It should be located in the root of the project folder. Is it there? I have to click here. Yeah. And it has many configuration values. You can see what are they doing by pointing to some of them and checking out the documentation. I have outlined in README some of the most prominent ones. We can explore this now quickly. So in brief, here in the target, we have configured that we're going to use ES6. This is a target that's maintained by most of the modern browsers. Now, if you want to support also the Internet Explorer, you'll need to set this to a little bit older standard, like ES5. Our dir is going to be called dist. This is where the transpiled files are going to be placed. The source maps are going to be generated for us. The configuration option that's called module is about which module system are we going to use in our program. It accepts value as ESNext, ES6, CommonJS, and if we want to explore this and go to the documentation page, we're going to see what will be the example output for that code that we have in our editor. What will be the produced outcome if we were to choose some of those different options. For our app, we're going to have this set to ESNext, which corresponds to the latest module system that is used by TypeScript at that moment. Okay, next is the JSX option, and when it is set to ReactJS, we will not need to include React in every TypeScript file. And here is the key now. For our issue with React not being imported in some of the files. And so now we have this set to ReactJS, and let's try what's going to happen if we remove this. It's already highlighted in more pale color, and when I remove it, nothing bad happens. So we don't have an error anymore. Okay, and the last value that we'll cover is ES module interop. Now, this ensures that our code that is going to be most likely written in ES6 and above will be compatible with packages and libraries that we're going to use that are coming from Node modules. Some of them are using other module systems like older JavaScript in CommonJS or Node.js libraries that have been adopted for the web. And so this option is very important. If we explore it, we're going to see how the transpiling will behave with or without it, and why is it important, and also it affects other configuration options, whether it's true or false. It's going to affect whether other options are set to true or false under the hood. Okay, now we have configured TypeScript. Okay, let's move forward. Now, scrolling to the next section in the README file, we're going to create a webpack config. This is a file that is a webpack configuration file. So in it, we're going to define some configuration options, which Webpack will read, and we'll know how to bundle our app. So let me create it. Okay. Now here, first we import some packages that are coming from Node modules. The path module, it comes with the Node.js. It provides utilities for working with file and directory paths. Here we're going to use it on various occasions. The next module we import is the HTML Webpack plugin. And down here in the plugins array, we are instantiating it, and we provide it with a path to the index.html file, which is the entry point for the browser when the browser loads our application. And what this plugin is doing is every time we build the application, every time we create a build, it will automatically inject a link to this JavaScript file in the index.html file. Somewhere here is going to inject that script tag pointing to the bundle. And so let's see what the other options are doing. The option called entry, it may accept a string the way we are using it now. The entry point for Webpack, we're telling that it's this file index.tsx, and also we are providing the paths to it. But in fact, later on, we're going to see that it can also take an object if we wanted to provide more than one entry point for the purposes of code splitting, so that we optimize the bundle. This also might be done here. Next option, output. Here we have file name, which will be the name of the bundle, in this case one bundle. But if we are using multiple entry points, we can also format passing some tokens in square brackets like that. Also, we're going to explore this later on. For now, it's just one file name. The path, logically, this is the path to the folder that contains the file. And resolve is an object which accepts many options for how Webpack is going to find the files that the modules, in fact, that we import like that. You can see here that we are not providing the extension of TSX, and this is because our TypeScript is configured this way. So in fact, we are forced to provide these extensions here to tell Webpack that it should import them without we having provided these extensions. And here the important thing to note is that the order that we list these extensions matters, because this is the order of which Webpack is going to look through the file system. So if we had one more file called app.jsx, here it would be imported instead of the tsx, because we are providing the extension before the tsx. This also needs to be taken into account. Okay, so next option, the module, is an object which takes various other options, but the most used one is called rules. That option accepts an array of so-called loaders, which are transforming otherwise incompatible files into modules that can be imported into our code when we import them with the import statement. If we have loaders for it, we can import images, we can import CSS, which originally wouldn't be possible to do with plain JavaScript or TypeScript. But those loaders are transforming this content and make it compatible with our application. So every loader object takes two main properties, the test and the use. And usually it also will have the exclude property. And what is doing the test? It's a condition, and it's usually a regular expression that will match the file name of the module. Usually, as in this case, we test for the file extension of the file name. And here we are testing for whether the file has an extension that will match .tsx or .ts only as well, because we have a question mark for the x. So next option, This is the use option. It takes a wide variety of options on its own in different forms. It can be a string, like in this case, it's the name of the loader, but it can also be a function or even another object. So maybe it's good to demonstrate how this might also look like. For instance, if we had a test for a CSS file like that, extension would be .css, and then we could have the use like an array, and then we could have two loaders, one after the other, like style and CSS loader. Now, in this case, those are processed in reverse order. So the CSS loader will run first, and the result of it will be passed to the style loader. So we can combine them like that. And also, if you wanted to do more adjustments to this loader, in other words, to have more settings for it, we could also use the object variation, saying loader, the name of the loader, the CSS loader. And then we could have, for instance, another option that's called options. And we say here source map true. So you see we are combining the string form with the object form, and also here the CSS loader will be processed first. There is also another way. Instead of using the use property, we could also take the content of this object like this. So here, in this case, we are, instead of use, we are using the loader property, and it accepts only the name of the loader. So if we wanted only to have one loader for the CSS with its options, we could do it like that. So next we are going to explore the exclude property. It takes a string or a regular expression that will match modules, or in other words files, to be excluded. Well, it can be also directories. In this case, it matches the node modules. We don't want it to be processed by TS folder naturally. So conversely, we can also have include option, which will take the same string or a regular expression. For instance, drawing their name to the src folder. So in this case, only files in the src folder will be processed by the ts folder. And even though it might seem a little bit confusing, why would we have both of them? Well, this is in case, because the include now covers the case of excluding the node modules because they are not in the source folder. But imagine that we had a folder that's called with this name within the source src folder, so it would have be necessary that we also have the exclude option. So yeah, this is just for demonstration purposes that we have them. Yeah, it can be used. And so in our particular case, what we're doing here, we are using the ts loader. Now I see here that I have missed something maybe, because I also want the JavaScript files to be processed by the ts loader, because even though in rare cases, we might want to include in our TypeScript files plain JavaScript files. And in that case, even though we have configured the TypeScript compiler to allow JS, but the webpack will not know how to load it. So those have to go through the TypeScript compiler. And I'm going to extend this regular expression saying also JS. And this way, we already have 4 combinations: TSX or only TS, JSX or only JS. Okay, I'm also going to fix this in the README because I guess you want to have this working if you are copy pasting it from here. So yeah, and in fact, this TS loader on its own is not going to do the work. What it's going to do is it's going to use the TypeScript compiler to do the work. That's why we also installed the TypeScript package along with the TS loader. So these loaders are only part of kind of extensions of Webpack to help with its work. Okay, moving down, plugins, HTML Webpack plugin, we already explored this. Now let's explore the dev server configuration. It contains options for configuring the Webpack dev server, the server that we're using for development on our local machines. Those options can be defined here in the configuration file, but many can also be used as options in the CLI. And here is an overview of the few options that we are using in this file. The port, well, logically, here we specify the port number for the dev server to listen for requests on. Open, if we have this set to true, we'll open the default browser when the dev server has started. And this is in case we have client-side routing like React router, which is most likely that we do. We need so that the web server knows that if we try to access a path that is not found on the server, that it should serve the index.html page so that the JavaScript router can do the navigation. And for those of you who are aware of configuring, for instance, Apache web server via the htaccess, there is a mode rewrite there, a module called mode rewrite. So it's a kind of similar thing. I have added a link here. Here we can even see that it can accept also an object for configuration, and we can even map URL paths to specific resources on the server, very similar to the mode rewrite of Apache. And also we need to underline that this is only for configuring the local development server. So we need to make sure later on when we are deploying the app on the production server that the configuration there will be similar to what we have here. Okay, and now we have walked through all the options in this file. Now it's time to run the application. For this, we're going to add these scripts to our package.json file so that we can run these commands more easily. Take this from here so that I don't waste time with any typos. Okay, and let's test the build and the serve. In fact, we can run it even without these commands using npx, like npx following the commands webpack serve and so on. Let's run it through the scripts that we just created. And then we'll start the dev server. Yeah, here is the command. And here is the app. It's listening for changes, and if we are going to make some change, it's going to refresh the page. Now you may notice that it was a full refresh. So as the next step, we are going to implement something called hot module replacements. But before that, let's see how is the other command going to run. npm run build, and the mode here is production, so it's going to create an optimized build. Here it is, this folder, it's ignored, and it contains the files. Right, let's move to the next task that we will do. It is to configure the so-called hot module replacement. It's abbreviated as HMR. And so what problems does it solve? We saw in practice when we launched the application, and when we change a file, the whole application got reloaded. And two things happen actually. One is that the application is reloaded, and the other is that we are going to lose any state that we have at that point in the application. And if we have to see this in practice, we can introduce a new component. Let's call it counter. And let's write the following component. It's going to be called counter. We're going to use a state. Let's this be called count, and then set count. Use state and initialize it to 0. And then we simply return div, not def, button with a non-click handler. Setting the count to the count plus 1, so increasing the counter. We're gonna call it increase, and we're going to create a container to display the counts. Like this, and we are going to use it in the app right here. And let's check now what's going to happen. Okay, here is the button, so I'm gonna click it a few times. And if we are going to change something here, let's say button click counter, and now we see that the whole page refreshed, and we lost the state with this. So let's see how can we improve this experience. Going back to the README. So if we check the documentation for hot module replacement in Webpack, we're going to see that it says that if our development server for Webpack is version 4 and above, we're going to have it enabled by default. In particular, this property is responsible whether it's enabled or not. I have included also documentation for this property, a link to its documentation, and as you can see, its default value is anyway set to true, so we don't even need to set this property here, this configuration option. So it was not the reason that we didn't have it working. The reason is that we are working with React, and it has its own way of managing the state, and we need a plugin for Webpack that's called React Refresh that will help with this state management. And we also need to install this other package, and that is for TypeScript loader that will enable the TypeScript to work with this React Refresh plugin. So we're installing this too. Now, because we are going to need this HMR only in development environment, we need to make sure that we only switch it on during the development server when we are serving the application locally, and we don't need this HMR when we are creating the optimized production build. So we will write this line over here for detecting the environment, and then we're going to include these two packages in this file, and then we are going to use it. First, let's use the React Refresh plugin. It's a plugin, and it's a different thing than the loaders. So we are going to test here if it is development. Then we are going to instantiate this as a new object, and because when this is development is equal to false, sometimes when it's not a development environment, we're going to have a false here, and we don't want this in the array. We are going to filter it by Boolean. We are going to filter this array, and then if it is false, we'll only have this item. If it is true, then we'll have these two items. So this is the purpose of this filter. And then going to the TS loader, the TypeScript package, we will need to convert this to be, instead of a string, to be object, like this. So because we need to also, a part of the name, we also need to configure options of this loader. And what we're doing here, those are called transformers, and we are testing if it is in development environment. We are triggering this transformer before the TS loader is doing the other work. And also we are filtering this array so that it stays clean if or empty array if this is equal to false. If it's a production build, then this array is going to be empty. So with this in place, now we can test again whether we have achieved what we wanted. So clicking it various times, and then let me change back the string to clicks like that, and we see that it preserved the state. This time it didn't refresh the whole page. Okay, so we have it working. One thing I remember that we were discussing when we were walking through these options is that sometimes we want to use the other form of use to use directly loader and this content instead of defining this use property like that. We can, if we only have one loader for this pattern, then we can define it directly like this. So we are simplifying it a little bit. I realize that I have messed it up a little bit here. Let me try to fix this in the easiest possible way. It's about how do we detect the development environment, and it's okay to have it like that, this line, but in order for this to work, for this environment variable in Node.js, in fact, it's not happening out of the box, but we'll need to set it ourselves. And it makes it a little bit inflexible. One way would be for we to install additional package. I have outlined here how this could be done. It's called crossenv, and then update the running command. But I see it a little bit awkward, so there is a better way to do it, and this would be to export a function instead of export a plain object from this configuration file. And here's how easy this can be done. We just convert it into an arrow function, and here we return an object. Let me go down to now add one more curl brace here and indent it properly. Okay, and now here this function will accept two arguments. One will be called env for environment variables, and the other one. So in order to preserve the command the way we have it, we're going to use this second argument, which gives us access to all the properties passed in this command. The env argument will give us an access to environment variables that were passed in this command, like that. And in this case, if we chose to use it that way, we would also have to add here the mode in this configuration so that Webpack knows how to what kind of build to make. So we would need to pass it here, but we're gonna go for this other way. I'm gonna replace this with a placeholder because that's a convention, and that's a convention for unused variables, as you know. And I'm gonna do this test is development over here. I'm gonna use argv mode. I'm gonna test whether it's a development string called development, and let me get this back. And yeah, with this we have made it a little bit easier, and also we saw at least one more way to export this module in the webpack config. Yeah, and that's also very useful. So I'm going to remove this line. I have updated the documentation here. So when you see the final version of this README, it's going to be in this form, in this shape. Right, so let's continue with the next thing that we're going to do now. And now we're going to take care about the styling of our code. We'll start with Prettier, the tool that I'm sure you are very well aware of. If you're not, of course, there is a documentation here. And especially I would recommend you to take a look at the configuration options. So let's install this package as a dependency. Okay, and now we'll create a file called Prettier rc to configure some options there. And we're going to have only those two options. For instance, I like a single quote instead of double quotes in the code. It might not be the case with you. And the print width, it's about these rules here, how wide should be the line. Well, the standard nowadays is 80, but might be also better to increase it a little bit if you are going to type TypeScript, because it gets usually longer lines than plain JavaScript. So yeah, that's completely up to you to configure your project's styling. Next thing, just to make sure that if we run the Prettier directly on the command line and not using the script that we're going to configure, maybe it's a wise idea to ignore the dist and the node modules, for just in case that it doesn't go to analyze all these files in there. So I'm going to create this Prettier ignore with these two folders listed in there. Okay, let me close some files. And now last thing is to make our lives easier by predefining these commands. So yeah, what will those commands do? If we type npm run prettier, it will write the changes directly. It will search all through the source folder for files with that extensions. If you only want to check, then you just run this command and it will print your list with files that will be formatted. Now those extensions are here for you to edit if you want. For instance, you might not want to format the MD files to go that far. So let's see how it works. Let's first check. Oops, without any space. And it says that there are 3 files that will be written. So in other words, edited and formatted. So now let's see what it will do with those files. For instance, here it added an empty line and it edited the double quotes into single. I guess the other files have undergone something similar, yeah. Maybe here it moved, yeah, it added a semicolon. Yeah, so it's very useful too. The next tool in respect to code inspection we are going to integrate into our project is ESLint. It's down here in the documentation. In fact, it's not just a style formatter like Prettier, but rather it's used for identifying issues in the code that could lead to some bugs. Here are the packages that we're going to install related to it. Yeah, as you can see, quite a few plugins. It's because it needs to be integrated with the rest of the ecosystem. So let's do that. First set of plugins is for ESLint itself and React and React hooks to apply some rules, even on React hooks in the functional components. Okay, next one. Actually, next two packages are for TypeScript. In the past, it's been called tsLint, as far as I know, this project, but now it's integrated into this main project, ESLint. Okay, next is for ESLint to function well with Prettier. In fact, we're going to configure the Prettier to be a rule of ESLint, to run as rule, and not to collide with the rules for in ESLint itself, because they may be rather they may have similar rules for similar problems. And the last one is the ESLint webpack plugin itself for integrating the ESLint to be run with webpack. I have also added some documentation on some few of those packages so that you have it for yourself to read in the README. Okay, now that we installed the packages, let's go for creating the configuration file. I have chosen the YAML format so that I can also put some inline comments. A typo. C. And the content. So let's see what some of the rules are doing. This is the parser that we are going to use, and that's coming from this package, the TypeScript parser that we installed, because we are using TypeScript and logically it cannot go with the JavaScript parser that it has built in. And next we are declaring the plugins that we installed also. Here, the typical thing that you should know is that if the plugins are starting with the word ESLint plugin, and here you can omit this prefix. As you can see with the React hooks, it's the same. ESLint plugin React hooks, only React hooks here, and Prettier as well. The options that are listed in the extend section are used for some predefined rules. Those are some recommended defaults that are coming from the packages that we installed, so that we don't have to list all the rules here ourselves. What we'll do is actually add rules that will maybe modify some of those rules, like some of those that we have here. The only thing that I'm going to say here is that this option Prettier, it's coming from ESLint config.Prettier package, and it turns off any ESLint rules that will conflict with Prettier rules, so that they can coexist together. So next, the rules, what we are doing here. This rule is for unused variables. We only allow the underscore. This rule, Prettier, it actually overrides the same rule that's coming with the recommended defaults, because it comes as an error level of warnings, and it makes the build to fail on every styling problem. Going down here, I have documented some of those options. This one is because we are using ES imports, like import and export. And here we list the environments that introduce some global variables. And if we don't do so, ESLint will warn us that we're using some undefined variables. Next thing we'll do is to add the ESLint plugin to webpack config. First, we're gonna import the package up here, and then in the plugins over here, we're going to instantiate the plugin itself with some configuration options, listing the extension, the file extensions, and the folder name. And also, what I like doing is to configure the dev server so that it doesn't create an overlay for all the warnings, only for the errors. It is over here on the dev server. The next and last thing is to add these handy commands into the package.json in the scripts. Okay, here below Prettier. And now let's run the commands to see if it will find anything unusual. Okay, it didn't find anything. So the command is working. And now let's also start the application so that we see whether it's integrated well with Webpack. It should work on file changes that we are doing. On every file change, it should run the rules, and if it finds some error, those will be reported. Actually, the warnings will be reported in the console, and if there is a compilation, if there is an ESLint error, it will result in a compile error, and the compile process will fail. Okay, and now it builds successfully. And if we introduce, let's say, a little bit more complicated error, let's introduce error related to the React hooks. As you know, those cannot exist in if statements. They should be defined in the function body directly. And if I do something like creating some condition in here, defining, making use of a hook, in the use state, for instance, and this should result in an error. Yeah, two errors. What errors did you find? Empty array is one error, and the hook use state. And also here we can see the rules that resulted in this error, the inspections, so that we know if some of the inspections doesn't work as we want, we can amend this rule here in the rules section. And if we check the browser, we see that it wouldn't even compile the application, the webpack. So in this case here, we should fix this error before continuing. So I'm gonna revert the code. I can demonstrate a problem that is not an error but a warning. For instance, some empty spaces, and that's also fixable with the fix option. Not all the problems are fixable with the fix option, but this one is. And what I can do is I can create one more console so that I can run separate commands here, and I can run npm run lint with the fix extension, and it's supposed to fix this problem automatically. Okay, here it is. And now it's all clean. And by the way, if there is a warning, there will be no warning overlay here. That would usually result if we didn't add this client configuration. Okay, so fixing this. And that may be pretty much it with regard to ESLint. If you need to change anything, you could even convert this file into JavaScript or JSON file. It's up to you. Okay, now that the code analysis and the code styling is in place, it's time to do the same for our application styling. We're going to set the usage of preprocessor, the SCSS. I have put a note here for those of you that like using styled components, for instance. This might not be necessary. They may go down a different path, but for those that are going to use styling in separate files, then this will be useful. So let's install various packages. And also the TypeScript type definitions. Okay, with this in place, now the only thing that's left for those loaders to be configured is to put this code in the configuration file of Webpack. Where is that? Okay, it's here. It should go to the rules array where the loaders are configured. Okay, so let's see what these loaders are doing briefly. We have 3 of them. Where should I explain it? Those are 2 different cases. We have one case where we test for the CSS extension, and if we have a match here, then these loaders are executed. As we saw earlier in the initial setup of the config file for Webpack, the loaders in the use property are executed in reverse order. So here first we'll kick off what it will do is to convert the CSS into JavaScript modules, because it will be executed when we have, for instance, import some CSS file here in the TypeScript. And then because it's not something that the TypeScript compiler will be able to understand, then these modules will be triggered, and it will convert it into JavaScript code, and then the result of this will be passed to the style loader, which will execute this JavaScript, and the result will be injected into the DOM. And in case if our file matches this pattern, in that case, first will be executed the Sass loader, because It's not even a CSS file, so it will pre-process this into a CSS, and then the output of this loader will be passed to the CSS loader, which will convert it into CSS modules. But there are two differences here from the previous usage that we saw. We also need some options here, and that's because we want that the name of each CSS style be changed in a way that it doesn't collide with similar names in other modules. So that's why we have defined this pattern here. If we visit this documentation, we'll see what these patterns mean, and we can decide to use different combinations of those. The other important property is this one. It says that for every import statement in our CSS files, like this, if this was a CSS file and we have import of another resource, like another CSS file, but in this case would be SCSS, and because it's a CSS loader, it wouldn't understand this SCSS. And here it says that it needs one number of loaders, in this case the SAS loader, to be executed for every import statement on that file, and then this to be passed to the CSS loader to continue its work. If this number was 2, it would mean that it needs 2 loaders before this one to be executed for the import statements. Yeah, so this is a little bit trickier to understand at first, but it is what it is. So next property is source map is maybe self-explanatory. And now we're going to do some styling on the application so that we see this in action. Okay, back to the application. As you can see, I have added some files in order to speed up the development process. We're going to use them to style the application and to restructure it a little bit. So let's start with the counter. Here, in order to use the counter SCSS that's here, we're going to import it first. Like that. And then we can use the styles that are coming from here. This counter class name, I'm going to use it over here like this. And this is the way we use the module classes. Let's start the application and see whether there is something changed now. Okay, and here it is. The change has taken in effect. Let's explore how the styles are applied. Yeah, here we can see that this is the class name that has been created by having this pattern here defined. So path name, and local, it is the way it is applied. And this last bit is the base64, 5 characters long. So we can count that it's 5 characters long. Let's go forward. Now here in the app CSS, what I would like to do is to use a main container instead of just using the feature component directly. So I'm going to replace it. And also we have here a header and a footer. So those ones are going to go like that. Header and footer. We're just testing how our application stack is working alongside the SCSS and everything else. Here we have a style that is CSS. Now we're gonna test how this loader is working. These two loaders. We can remove this one. And importing it like that, if we explore what's going on here, there is a part of some styling on the body and the HTML. There is one class here that will be applied whenever this class is matched. So let's create here a section with a class name. What was the class name? Container. Okay. And now we see that the project has the app has been changed. I have leftover here that I need to remove. Yeah. Okay, so the only thing here that I see that's not the way I want it to be is the height of this div container, and that's located over here. Now I can create a style sheet file here and import it, but it's just a minor thing that I need, so I'm going to style it directly. And that's going to be height of 100%. That's necessary here. I think, yes. So now it looks the way it's supposed to. If we explore the other styles, we're going to see that they are all bearing their corresponding paths and module names and class names and the 5-character base64 string. So yeah, works well. So we're gonna move on. Okay, now we are gonna move to the next thing, which is gonna be asset management. In order to be able to use asset files like images or fonts in our code, we need to instruct Webpack how to handle, or in other words, how to load these files in our code. And luckily, as of Webpack 5, we have built-in asset module support. In other words, we don't need to install additional loaders to deal with asset files. We only need to configure Webpack to enable this feature. And here is the chunk of code that we're going to add in the rules. Similar to our loaders, it's going to go below this one. So what are we doing here? We're testing for file extensions that are typical for images and also file extensions typical for fonts. If you want to customize the file name that's going to be generated during the build process, I have added here one file. And so when this file is moved to the dist folder, that's going to be the target for the build, it's going to get renamed, and I have added here this link. If we follow it, I can show you. Yeah, it's here. So here we can see some similar examples to the one that we're going to apply. And here is about what I'm talking about. This configuration option is by default assigned to this template strings, and it's a good default. But in fact, I would like to also see the image name in this new file name. So I have added it here, and also preserve the hash and extension. It's going to be in a separate folder. In fact, that's a similar example here. I remove the query because the image and font type, file types, I think they wouldn't need this query. Template string, but it's up to you to explore the use case of it and use it when necessary. And why do we use hash? In this context, in the context of this option, unlike the context of the output file name, because here we can use very similar template strings. So in this context, the hash will be formed based on the content of the file. So this is exactly what we want. We don't want this hash to change every time we change any of the build files, like it would be the case in the output file name. But here it's going to change only when the content of this particular file changes. Let's move this property in here. It's going to go in the output section like this. And let's try to add a logo image in the header to see what's going to happen. So I'm going to import this new file. And we can see that it's not recognized. So why is because we are in the environment of TypeScript and it's complaining that it doesn't recognize this file type. So this is where comes the second part of the instructions. And this is to add this type declarations, TypeScript type declarations. I'm going to create a new file where other such type declarations might go, which are going to be used globally. This is one thing, and the second thing is to configure TypeScript to pick up this file without we having to import it anywhere. And when I save it, we see that the error here disappeared. It's only unused variable now. And let's create here an image with a source. It's gonna be taking this logo image. Okay, and now let's run. Okay, it's here, but it's kind of huge. Let's explore it though. So we can see that it's served from this assets folder, and the name has the shape that we wanted. So this is coming from this configuration option asset module file name. Yeah. So let's do something about the styling. We're going to style the image. Defining the width should be enough. Yeah, and the other thing is to put some space here between these two elements. I'm gonna do it in the header. It's a flex type of display, so gap 5 pixels. Yeah. So this is how it works, and we're pretty much done with it. Now let's explore one more problem that is similar to the asset management that we just covered. For this case, we're going to open the index.html file, and here we're gonna find one root element that we have for the entry of our React application. That's why it bears the name root. So here we have a styling, and because it is a very brief style, I decided to do it inline. But imagine that we had more code here, for instance, and we wanted to export this styling into a dedicated file. And in fact, let's do this case to see what's going to happen. Uh, we're going to add here styles.css, and here I'm gonna select this uh, element with ID root, and then I'm gonna define the height to be 100%, just like here. I'm gonna remove this style, and now I'm gonna link this style sheet. So this is what I want to achieve, having the styles CSS file. And now I'm gonna build the application to see what the build is going to be as I expect it to be. Okay, build is here. And so here we can see that the index.html file has been included into the build, but the styles CSS file is not here. Let's, in order to be sure, to serve the application with the serve package I have installed globally. Okay, and we can see here that indeed this style sheet is missing because the application height is not set to 100%. And so here is the place to fix this. Uh, Following the steps that I have outlined here, we are going to use one additional plugin that's called Copy Webpack plugin. And from what its name says, it is a plugin that will copy certain files from one place to another. So let me add this to the dependencies. I've copied it. Okay, I have copied the copy webpack plugin command. Okay, ready. And the configuration here is not that hard. We just have to include it. and then add this snippet of code to the plugins array. Where is this? Plugins here. Okay, so let's explore the configuration of this object that we create. Let me remove this comment because so patterns, yeah, from two, it's self-explanatory that we are moving from public dist to the dist, from the public directory to the dist directory. And here we are ignoring this index.html file because we have another plugin that is taking care of it. So we don't want it to be copied, otherwise it may overwrite, for example, this file that's going to be created by this HTML pack plugin. And so this file is important for us. We don't want that. So that's all. And now when we run the build process again, and yeah, here we see that the styles file appeared. And let's run the application for just in case with the serve. I'm serving the dist folder, not running the development server. And yeah, it's here. So we can see that the style has been applied. We can verify it by clicking on it that it's been loaded. And so yeah, that's all for this task that we had. One more thing here that's important to know that is that it's not only in cases where we have CSS files. If you explore the settings here, we are copying all the contents. So it might be that we have subdirectories here with files inside them. They are all going to be copied recursively to the dist folder. In situations like that, where you may have any kind of static content here, a part of the index.html file, or a part of any other so-called template files, because you may have more than one entry point in your application, but that's a little bit more advanced case. Anyway, it's enough to have as a starting point for this concept of copying files. So let's move on to the next topic that we are going to cover. Is something small. Now, when we have here this folder, and we just run builds one after the other, and you may expect that this folder to be replaced, but in fact what happens is that it gets overridden. In other words, the files that are changed are overwritten and all the other content is preserved the way it is. Now, to see this in action, what we can do is to simply, for instance, delete this file that we just added. And now let's run another build and let's see whether this new build is going to remove the styles file that we have in the dist folder, which is what we would expect. Yeah, now here is one error that I expected to happen. That's the other thing. Let's add one more property to the configuration of this copy webpack plugin. Now what we did was to create a case where it wants to copy something from the public folder, but there is nothing to copy because we are ignoring the index.html file, and it complains that it's unable to locate files in here to copy. And so there is one property that we need to add. It's called no error on missing. Yeah, I got out complete. That to be true. And this is the way we configure it. Now, I don't know why didn't they do it to be the default case, but obviously they want to show that the plugin is here, but it's doing nothing. The other thing that you can do in this case is to comment out this piece of code if you come into a situation where you no longer need it. But anyway, I'm gonna add this property here. I'm gonna add it also in the README. Where is this? Yeah, over here. Global options over here. So now let me run this again and see whether the styles file will disappear the way we expect. And here it is. A new build was created, but even if I refresh, yeah, the file is here. So there is a solution, as I have outlined here in the next section in the README. The only thing that we have to do in order to enable this feature is to add this clean to option and set it to true in the output. So up here, output, one more option, clean set to true. In such cases, if you don't have this property, you may have a distribution bundles with leftover files inside. Not very nice. So now what I expect to see is that this styles.css disappears. Yeah, and we saw that indeed it got deleted from the. In fact, what happened is that the dist folder got deleted, the entire content of this folder, and it was put there again, but this time it only contains the files that are necessary for it. So I'm going to return this styles here, and I'm going to, yeah, the link is here, so. Okay, now that we have configured the cleaning of our dist folder, the housekeeping, let's explore the content again, and let's concentrate onto the next problems that we're going to try to resolve. One problem here is that the way we have configured Webpack, our bundle file name is going to be always called with one and the same name. And you can imagine that at some point this might create some caching issues to your users when you upgrade the version of your app with a newer version and the file name is the same, then they may need to force refresh the browser in order to get rid of the cache and load the newer version. So you know that the way to overcome this is to just add some random cache here, and this way force the browser to reload this particular file. That's called cache busting. So in order to configure this, we're going to go to the output section of this configuration, and we're going to change this bundle, this fixed name, into something dynamic, like instead of bundle, I'm going to use this string template called name, and one more that's called content hash. So the name By default, internally coming from Webpack is called main. So instead of bundle, we're going to have a new name that's called main. Now, why am I using a placeholder? It's gonna prepare for another use case when we might have multiple entry points, which is not very frequent uh, because those are supposedly single page applications and they usually have only one entry point. But if you didn't want to have your application necessarily to be single page application, but you wanted to have, for instance, 2 or 3 different sections that load with different entry points by page refreshing, then you don't need to have only one bundle full of them. You would like to split the code into files that are gonna serve the different entry points. So in this case, this name is going uh, to bear the same name as the key of this entry point. You may have another entry code about, for instance, and so on and so forth. So yeah, that's why I'm gonna leave it like that. Yeah, and in this case, if you had more than one entry point, you would need to uh, also create more instances of this of this plugin to create your templates automatically, and also you have to configure it here properly, but it's not what we're gonna do now. So yeah, should we run another build to see what happens? Let's do it. So here we can see that we have this called main and some random hash. So now let's explore the content of this folder with the ls command to see the file size. Here we can see that it's nearly 150K, and that's because not because we wrote so much code. I would like this to be the reason, but it's not. It's because it contains all the node modules inside. I mean, the packages that we took advantage of. And we might want to split our code from these vendor files with the purpose that this time we might want to take advantage of the browser's cache. Because if we had some small change in our app, then this file name will change and the users would need to load the whole bundle again, including the node modules, despite that we might not have taken advantage of new packages. So let's do also this splitting so that we have our code in a separate chunk. This is going to be achieved by, I have included documentation here. It's called split chunks plugin, and it's included by default in Webpack 4 and above. So the documentation is here. If we go to the page over here, you can find these properties. So this one is very important, and by default its value is set to async, which means that only dynamic imports are going to be exported into separate chunks. Dynamic imports, you might see it over here in the examples. This is what is dynamic import. So you'll load the new JavaScript code only if the user visits that part of your application. So if, for instance, this was my page and you were roaming here around, you wouldn't need to load JavaScript that's specific for this other page or for this page. That's why here I might have chosen to use dynamic import, so lazy loading. And in that case, logically, Webpack, the way it is configured out of the box without you having to do any configurations of that sort that we're doing now, it will split that modules into separate chunks. And this other runtime chunk, we might configure it to be single. Again, it's going to be exported. There is a small amount of code that Webpack generates to be executed at runtime. And every time we create a build, it might not change. So we also want that code outside. And one more purpose for this, if we had that case that we had multiple entry points, then they would reuse this chunk, all of them. Otherwise, this code would be copied into each one of those entry points. So let me put this in place. It's a top level configuration. I'm going to put it over here, closer to this part here, to be in front of our eyes. And now let's create another build. That's zero. Let's explore now the file sizes. And here we see that in this chunk, it's nearly 140K. So logically, we may consider that this is the node modules. You can also customize the name, but it's up to you to explore this in the documentation. It's not too hard to do it. This is our custom code now, only 5 kilobytes, and that is under 2 kilobytes, the runtime code of Webpack specific code. And in order to see this in action, let's do some small change somewhere in the app. It doesn't matter where. Let me put some random string and create another build. We're going to be able to verify which files will need to be reloaded by the browser when we make this change in our custom code. Okay, if we use this previous output to verify the file names, we can see that 0b7, 0b7, 492. Yeah, it seems that this name didn't change, so we didn't use any new imports here coming from node modules. So obviously this the biggest chunk didn't change, and our custom code we have a change here. So the hash has changed. So this one is going to be reloaded, and the runtime is also having the same, yeah, the same hash. So this name is the same. So yeah, splitting our bundles into separate files may help if our app grows larger. But let's explore now also the size. 5188 here, 5173, yeah, maybe about 15 bytes larger because we added some string, and here 65, this one didn't change at all. 939, yeah, this one also didn't change. So really the content only of this small bundle that is containing our custom code has changed. And yeah, so that much about this optimization. you can go much farther, and it's recommendable that at some point you get to know this in more detail if you want to have highly optimized apps and enjoy happy users. Yeah, so we're going to leave it here. Okay, now that we approach the end of the video, let's explore one more important aspect in this project starter. It's about debugging and how we see our code in the browser's developer tools. Of course, you know that if we lack source maps, we're not going to see very useful things there. I have started the application, and I can show you how are the files displayed at present. Let's see this one. Yeah, so this is just a transpiled version of our TypeScript. Not very nice to work with. So the way to configure the generation of source maps for our custom code, it's a one-line configuration, fortunately. So it's about this dev2 option. We're going to have two different values for whether we are in development or in production. So I have chosen in between many other values. Let me show you the page. Yeah, there is this table which outlines the different options and the different values for that option and their advantages and disadvantages. So here for this one, they say that it's a recommended choice for development builds with high quality source maps. So yeah, we want high quality stuff in our project. So this is for development, and for production, I've configured it to use this value, which is specifically designed for production. Yeah, I cannot find it here, but it's somewhere. Yeah, it's here. It's recommended for production, and yeah, it displays original code. So, but there is one thing here that why do you need maps, source maps for production? This is in cases where you may use tools like Sentry, logging tools that will record your errors and will trace them back to your original source code. So even though in this case it is highly discouraged that you upload your source maps on your production server, on the web server, to be visible by the wide public, because this way everybody can see your original source code. So this is not what you want. Fortunately, Sentry has a way that you upload those source maps to Sentry directly and don't upload them in the production server. In cases where you have where you are developing some internal tool that is going to be used only by yourself, then in that case you can of course upload the source maps, and I think Sentry was going to pick them up directly from there without necessity to upload them. Yeah, you have to check this to be sure whether it's the case. Okay, and yeah, if you don't want source maps for production, you simply can put here undefined like that, and source maps will not be created when you run the command to build the app. So now let's stop the application and run it and start it again. Okay, I forgot. I forgot that I need to put this line in place in the configuration. This is only our README. Let me put it over here somewhere. You may choose more adequate place for it. Okay, so now let's explore again. Counter. Yeah, now we can see that it looks very nice. It looks almost identical to our original code. Let's see. Yeah, this is the original file. Let me introduce something specific for TypeScript even. The return type of the function. So yeah, it's here. So we can put a breakpoint. We can even choose where exactly on this line it should be triggered in the increase. Yeah, it's here. It works. Okay. Their thing is to create a build. There is an error that you see here, and this is simply the missing favicon. I'm going to leave this to you. We configured the static asset management so that it will be copied to the build folder, to the dist folder when you add it. So now we're going to create a build, and we should see the source maps next to each JavaScript file. Here they are. So this is how it looks like out of curiosity. Yeah, so we have it. Right, and one more thing that we're gonna do in this video, the last but not least, the way it's usually set, is to make sure that our testing works as expected. So let's add one test for one of the files and make sure it works. Okay, first let's add this convenience scripts to our package. Yeah, we're gonna replace this default value here. 3 commands, you know what they would do. So this next step, let's go for the test and see how it is going to run with coverage without having this value. Okay, so this is going to be the test. What's it doing? We are using the user event from this package so that we can do some user interaction over here. So first we load the components, get the elements, the buttons, then the counter element. By the string, it's supposed to show 0 clicks. Then we perform a click. Then we make sure that the text has changed into 1, and this will validate our case that indeed the click has been counted. So let's make a file with this name, counter test, in the source folder. Now we are ready to run. The first time you run it, it may take a little bit longer, but any subsequent runs will go considerably faster. Okay, so we have it working. The test was successful. Now let's try the other commands. We want to try this one, the cover with coverage. Okay, so It reports that we have 100% coverage. Well, it would be nice if it was the case, but unfortunately, without this configuration that we were about to add, uh, collect coverage from listing all the files that it needs to consider. It only takes into consideration without this only the files that we test. So for counter, fortunately, we have 100% coverage. But if we want to see the overall coverage in all the files in the source folder, let's add this section here to the Jest config, maybe on the bottom. And now let's run again this coverage test. Right, and now it analyzes the whole set of files within the source folder to calculate the overall coverage. Okay, so here is the table. We see that this time the picture is different. We don't have definitely 100% coverage. If we wanted to see though a little bit nicer picture, we could even serve this coverage folder that contains all this information with this server. Right, so it contains this information here in this folder, icon report, and yeah, here if we had many files, we could search through them and see the particular situation in any one of them. Um, yeah, we have 20% of the lines, function statements. Yeah, it's up to you to analyze this. And by the way, this coverage folder is considered to be a good thing to have it under version control because it presumes that you're going to share the results with your teammates. So I'm going to leave it and commit it to Git. And with this, we have pretty much a good starting point to build upon this starter project and customize it the way we like according to our particular use case. And here we are at the very end of the video. Let me congratulate you for making it that far, this lengthy tutorial. Also, let me remind you that you can find all this starter project published in GitHub. It's over here in this URL, which will be available in the description of the video. The whole README is here on the front page, and there is also a discussion page, which you can use to publish any comments or questions if you like to do it here. And thank you for watching.